what if gravity was 10 times stronger? Gravity. It's a fundamental force without which there'd be chaos. It's what keeps the planets in place and what ensures our feet are on the ground. But what would happen if it received a sudden power boost? This is Unveiled, and today we're answering the extraordinary question, what if gravity was 10 times stronger? Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more fascinating content. Our interest in gravity really starts with Sir Isaac Newton's law of universal gravitation, which says that any two objects, or indeed any two particles, exert a force of mutual attraction between them. The strength of this attraction is found by multiplying their combined masses and the gravitational constant before dividing by the square of the distance separating the two bodies. It sounds pretty complicated, but it's a formula that essentially shows how and why our lives, our planet, our galaxy, and our universe are shaped and positioned in the way they are. Generally speaking, the force of gravity between any two things is quite weak, but its effects are much clearer whenever very large masses are involved. Considering that the Sun accounts for more than 99% of the solar system's entire mass, the star has by far the most powerful gravitational pull in this particular corner of the Milky Way galaxy. As a result, and as we all know, Earth, every other planet, and everything else in this star system orbits around the Sun. Meanwhile, though it's nowhere near as powerful as the Sun, Earth's core exerts a gravitational pull attracting nearby objects to its surface. This includes the Moon, which stays suspended in the sky thanks to its own gravitational force, which also causes tides to occur on our particular planet. Everything on Earth, from the roots of the trees to the cells in your body, is effectively kept in place by the planet's gravitational strength, calculated to be 9.8 meters per second squared, which is otherwise known as 1g. So if Earth's own gravity suddenly increased tenfold, everything would change and not for the better. Assuming that the force skyrocketed without any alterations to Earth's general composition, a 10g scenario would see everybody and thing within Earth's sphere of gravitational influence weigh 10 times as much. While mass remains constant regardless of an object's location, weight changes depending on the gravity acting upon it. The sense of weightlessness associated with space travel is a direct result of weaker gravity. But we'd now be at the other end of the spectrum, with Earth's new gravity meaning that everything feels 10 times heavier than before. Imagine a 200-pound person who suddenly finds themselves strapped with an extra 1,800 pounds worth of weights, and then expand this incredible burden onto the entire planet. Performing just a single step suddenly becomes an accomplishment of Herculean proportions. It just wouldn't be possible. Even if you survived the initial smack to the pavement, the human body would more or less instantly begin to fail. Our bones would be crushed, while the heart, which is also being crushed, would need to beat faster to keep the blood flowing as usual through arteries and veins which, you guessed it, are also being crushed. In a 2018 study at the University of Zagreb, 3 physicists sought to determine a gravitational range survivable for the human body. They estimated that a specifically trained athlete could potentially function at up to 4 times our current gravity, but once this threshold is passed, even the fittest human body would be incapable of lifting itself off the ground. Of course, while our own brutal biological struggles are playing out, the material world around us would be in disarray too. Planes would fall from the sky, cars would grind to a halt along roads and bridges that would crack and break apart, trees would topple and buildings would fall. Further afield, artificial and natural satellites, including the International Space Station and, yes, the Moon, would need to somehow start orbiting the Earth at 10 times their current speed. Failing that, they'd both be close enough to be sucked in and to collide with our increasingly doomed planet. Due to the massive distance separating the two and the Sun's far greater mass, Earth's upgraded gravity shouldn't alter its relationship with its star quite as drastically. Nevertheless, the shift would potentially push Earth out of the solar system's habitable zone, meaning that its climate would also grow increasingly unstable. While that's all happening though, Earth's basic credentials as a planet will have increased. Celestial bodies are considered planets when they possess enough self-gravity to maintain a spherical shape. So with 10 times the force, what's left of Earth is dragged closer to its core, and it's arguably more planet-like than ever before. Say the change isn't solely restricted to our single planet though, and gravity is universally multiplied by 10. We'd see similar effects elsewhere. The solar system currently exists in near-perfect balance, allowing for one-to-one gravitational relationships between various bodies which maintain a steady equilibrium. Such a significant shift in gravity would throw this into severe jeopardy, as the planets shift closer together to try and maintain their orbits. Even the sun itself could struggle in the new conditions and eventually burn out quicker. And that's just one star in one system. Elsewhere, other stars and whole galaxies are pulled closer together, theoretically causing the entire universe to either reverse or significantly slow down its current expansion. Finally, this scenario assumes the increase in gravity happens now rather than at the beginning of, well, everything. Although much remains a mystery, the Big Bang Theory is widely held to offer the most plausible explanation for the creation of the universe. It proposes that the cosmos started out cramped in a single, immensely dense point before there triggered an explosive expansion which continues to this day. But would such an event have even been possible if the force of gravity was 10 times stronger from the outset? As the trigger for the expansion is still unknown, it's impossible to say for sure, but dramatically increased gravity isn't likely to have made the process any simpler. As an inherent fundamental part of life, we tend to take gravity for granted and don't often stop to think about how important it really is. But it's a major reason why Earth can maintain its status as a livable planet. Although a tiny gravitational increase or decrease might be manageable, humanity could only withstand so much pressure before buckling under the strain. And that's what would happen if gravity was 10 times stronger. What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.